Okay. Right. Good evening. We'll start. How about my audio and the video? Let me also check from my end. Right. It's clear, right? Start. Isn't the audio, sorry, video clear today? It's clear enough, right? Okay. Right. Enough now. We'll start. Right. Okay. So we are with S2A day 12, right? S2A day 12. And today we are to start. We are planning to start the discussion on matter and radiation, right? We have already finished matter and radiation in the theory class, right? Reverse class, reverse theory class. And I'm taking today for the discussion of matter and radiation questions, right? So I'm planning to discuss all the past wave MCQs under radiation and photoelectric effect, right? Today, I think here we have around 35-40 questions, right? So I'm planning for a little bit more questions compared to other days. In other S2 discussions, usually I discuss like around 20 questions per day, but today we have more, right? So let's see, we are just 13 weeks from the exam. We are just 13 weeks from the exam now. It is exactly 13 weeks and 3 days now, right? 13 weeks and 3 days. And time flies these days, right? Time flies these days, right? That's how it is. That's completely normal, because when we engage with something else, when we are busy with something else, right, always time flies when we are busy with something else. Otherwise, now if you are just staying without doing anything at all, then for you time won't fly, right? But if we are busy with something else, when we engage with something else, right, when we are busy with something else, right, always time flies. Always time flies. Okay, then we'll go to the discussion. I think live is shared in all the channels and groups, right? Yeah, it's shared. Right. Okay. Okay, right. It's shared. We'll get into the discussion. If you haven't downloaded the questions yet, I have pinned the link in the live chat, right? Go there and you can download it, right? And if you are already a regular student, if you have my Tute of Madan edition, there you have all the questions also, right? So either way, I think all of you have got the questions, right? For anyone, even if you are not joining the regular class, totally fine. You can find the questions here through this link, right? Okay, then let me share my screen. Without any ado, let's get into the discussion. So I think you can see my screen now. Visible, right? Okay, visible now? Right. Let's get into the discussion. Question one. Question one. First questions are from radiation, right? Question one. Figure shows the variation of intensity of radiation I emitted by a black body with the wavelength. Right? We call this I lambda characteristics curve. Right? In theories we discussed. We call this the I lambda characteristics curve, right? I lambda curve, I lambda characteristics curve, I lambda, right? Emitted by a black body with the wavelength A. With the wavelength, it should be lambda, not A. It's a typo. It should be lambda, right? As the temperature of black body increases, the maximum intensity, right? So this is what happens now. We discussed under Stefan's law and Wien's law. Laws the kind of under Stefan's law and Wien's law, we learned one is when temperature increases, these two are proportional. And when temperature increases, lambda m decreases, these two are inversely proportional. Right? For temperature, I is proportional. For temperature, I is proportional. Right? Now, Stefan's law again prove up. What was the equation? Stefan's law. Right? E over T equals sigma AT to the power 4. Right? E over TA is intensity. E over TA is intensity. Wait, my screen is going on. 1 second. Now fine, right? Right, okay. E over TA is E over TA is sigma T to the power 4. E over T is called intensity. International temperature, right? And these two are the two relationships we had. These two are the two relationships we had, right? Now go to the statements. First one, IM increases, and the position of IM shifts towards longer wavelengths, right? IM increases when temperature increases. IM increases කියන කාරණේ. IM කියලා කියන්නේ maximum intensity increases. Sorry. And මේ දෙක නෙවෙන්නේ when temperature increases. See, when temperature increases, I increases. But when temperature increases, lambda decreases. Right? Only these two happens. Increases. IM increases and IM shifts toward the shorter wavelengths. Yes, shorter wavelengths, lambda decreases. Then that is true. That is true. Position of IM shifts toward the shorter wavelengths. එලිම මේ relationships දෙකෙන් තමයි answer එක ගත්තේ. Right? Clear? Next one. Second one. The sun radiates energy at a rate of E per unit surface area. At a rate of E per unit surface area. Assuming that the sun to be a black body, if its surface temperature is given by sigma Stefan's constant, right? Then again, Stefan's equation. Go to Stefan's equation. E over T equals sigma AT to the power 4. It says the sun radiates energy at a rate of E per unit surface area. At a rate of E per unit area. Then this whole thing, E over TA is given as A here. Is sigma T to the power 4. E over TA is given as E now. Right? It is given as E. Then E equals sigma T to the power 4. We need temperature. Then T to the power 4 equals E over sigma. T equals, take the fourth power 1/4, power of 1/4 in both sides. Then E over sigma 1 over 4. E over sigma 1 over 4. First one, right? First one. in black body radiation, we have only two equations, no? Right? So finding the equation is easy. In black body radiation, we have only two equations. One is Stefan's equation, the other one is Wien's equation. Only two equations. So only two equations we have. Only two equations we have. Right? Check with your answers, and if you are trying with me, you can take them down. If you have tried already, check your answers. Third one, unit of Planck's constant is, that is easy, right? What's the equation? Equals HF. Equals HF. Unit of Planck's constant. Then unit of H is given by unit of E over unit of frequency. Frequency is hertz. Hertz means S minus 1. So this is J's, joule seconds. Second one, joule seconds, J's, joule seconds, right? Joule seconds, J's. 4. Figure shows the black body radiation curve for a body at a given temperature. Again, this is an I lambda characteristic curve, right? I lambda curve, I lambda characteristics. Consider the following statements. It should be at a higher temperature, not higher, at a higher temperature. It's a typo. At a higher temperature, right? First one, lambda m would be lower. When temperature increases, Im increases. I is proportional. With temperature, lambda m decreases. That is inversely proportional, right? Then lambda m would be lower at a higher temperature. No? Yes, lambda decreases. At a higher temperature, lambda decreases. So it is lower. At a higher temperature, right? At a higher temperature, lambda m is lower. Then intensity would be higher. Yes, because T and I are proportional. T and I are proportional. Intensity is higher. Velocity of the emitted radiation would be higher. Velocity of the emitted radiation would be higher. Velocity of the emitted radiation. We know V equals F lambda, no? Right? V equals F lambda. Then when lambda increases, when lambda decreases, velocity of the emitted radiation will be higher. There's a typo, it seems. Once again, lambda would be lower. Intensity would be higher. Velocity of the emitted radiation would be higher. Velocity of emitted radiation would be higher. It seems there's a typo there because the correct answer is not here. Velocity is lower. Lambda is lower. When lambda is low, velocity is lower. Right? Then this is wrong. Should be only A and B. It should be only A and B. Should be only A and B. Seems a typing error. Yeah, it seems a typing error. Then consider only A and B. A and B. Consider only A and B. Consider only A and B. Right? Consider only A and B. I extracted the questions from Pesro book. I think there's a error in that questions in the Pesro book. I guess it seems. Right? Okay. 5. Two blocks A and B initially at 80 degrees Celsius and room temperature 30, respectively, are hung from insulated strings in an evacuated and conducting enclosure, which is at room temperature. Right? This is the enclosure that is at 30, and these two are at 80. Right? These two are at 80. Both of them are at 80. Both of them are at 80. Right? The enclosure is insulated from outside. Enclosure is insulated from outside, which means there's no heat comes in or goes out from this insulated layer, right? No heat comes in or goes out from the insulated layer, right? The enclosure is insulated from outside. That's a Good point. Which of the following statements is correct prior to the system being reached equilibrium? Reaching equilibrium means what? Equilibrium. Reaching equilibrium means, right? Their temperatures are going to be equal. Temperatures are going to be equal. Reaching thermal equilibrium means temperatures are equal. Reaching a thermal equilibrium, which means temperatures are going to be equal. Temperatures are going to be equal. Right? Then temperatures of A and B and enclosure remains unchanged. No, they are going to change. But about enclosure, there's one thing. About enclosure, the thing is enclosure is insulated from outside. Then there's no heat inflow outflow. Without having any inflow outflow, its temperature cannot be changed. No heat conduction. Right? No heat conduction. Then its temperature cannot be changed. So that enclosure should be at a temperature. Enclosure should be at a constant temperature, right? That's one thing. Enclosure should be at a constant temperature, right? Then enclosure remains at room temperature. It's correct. It's at a constant temperature, right? And temperatures of A and B changes, yes. Then A and B changes and it is reaching the equilibrium. It is reaching the equilibrium. It should reach 30 at the end. It should reach 30 at the end. And enclosure remains constant because there's no heat conduction with the outside, from the outside though to the outside, right? So it's true. That's a little bit tricky question. A little bit tricky question, right? A little bit tricky one. Clear, right? Let's move on. 6. ABC, and D are 4 cups of same size. A and B have rough black surfaces, and C and D have smooth shining surfaces. A and C filled with hot tea at 50 degrees Celsius. A and C, label this as, this is missing actually. This is A, B, C, D, right? This is how it should be, A, B, C, D, right? A, B, C, D. And A and C are filled with 50 degrees Celsius. A and C, right? 50, 50, and the other two are filled with cold tea at 10. 10, 10, right? So in radiation, this is what we have learned. If a surface is high in emissivity means black and rough, black rough surfaces. For black rough surfaces, this is what we learned. For black rough surfaces, both emission and absorption, right? Both are higher. එකක් විතරක් එහෙම අඩු වැඩි වෙන්නේ නැහැ. මේ දෙක මතක තියාගන්න ලේසි, right? Both are higher, right? And when it comes to white smooth means shining, right? White smooth surfaces, both emission and absorption are lower. Right? So that's the logic. Then A is at 50 degrees Celsius and there is a black surface. Black always absorbs and emits heat faster, right? Then A cools faster, it is correct. A cools faster than C, correct. And for B also, B is going to warm. Absorption is also higher. Then black top surfaces are always going to emit and absorb heat faster, right? Then first one itself is correct, right? A cools faster than C, correct. Because C is white, C is a white surface. And B warms faster than D, it's also correct, right? This is what we learned in emissivity, Stefan's law, emissivity and Stefan's law, right? And you have touched on this thing before also in thermal, right? අපි thermal වලත් ඔය part එක කරනවා in law of cooling, right? ඒකෙන් පොඩි දේවල් හිතන්නත් පුළුවන් law of cooling එකනොත්, right? There is heat convection, right? But here this is heat radiation. Not similar but comparative. Right? Next. 7. A star S rotates about its own axis as shown in the figure. Which of the following graphs best represents the observed distribution of intensity 1 I as a function of wavelength? It should be lambda. wavelength lambda of a spectral line emitted by a certain gas in the star when viewed from Earth. Okay. The broken lines represents the expected intensity distribution expect line if the expected intensity distribution of the spectral line if the star does not rotate about the axis. Right. Listen. Now when it rotates, what happens is now this is going to connect with something you learned in Doppler's effect. Right. See, this is a good combination. Something is going to connect with Doppler's effect because I'm going to think of the frequency here. Frequency and lambda. Now we are viewing from Earth. And what happens here for the star is it rotates around. When it rotates, when velocity is towards Earth, when velocity is towards Earth, we know velocity towards Earth means as a frequency from Doppler's effect, we are going to hear a higher frequency. We are going to hear a higher frequency. If a higher frequency is heard, lambda is going to be low. Lambda is going to be comparatively lower. Right? Lambda decreases. Higher frequency increases, lambda decreases. Then wavelength of the this line, right? Spectral line, when star rotates is a comparatively lesser value compared to the stationary case. Wavelength is less. Wavelength is less, right? And the other thing is, we know area of I lambda curve. Area, right? See how these things are connected. Area of I lambda curve gives energy. Right? So even though it is stationary or moving, energy remains same, which means areas of these two curves must be equal. Right? Definitely these two areas are going to be equal. Then from this, wavelength decreases. Then with respect to this dotted line, wavelength should be decreasing. Wavelength decreases. When wavelength decreases, right, this line is going to get wide. It is going to widen. And area should be equal. Areas are equal because energies are equal. Right? Then wavelength has decreased in 2 here and 1 here. Wavelengths are decreased. Right? And both of them should have same energy. Right? 2 is gone actually. 2 is gone because now initial variation has been this and now final variation is completely different from the first one. No? Cannot be. Then only acceptable answer is 1. Right? This part is coming from, this is a good question. This part is coming from Doppler's effect. The things we learned in Doppler's effect. Right? When velocity is towards the observer, frequency increases. When frequency increases, lambda decreases. Right? When lambda decreases, this variation is going to be wider. Right? Going to be wider. And area is energy. Then both areas should be equal because energies are equal. Right? Then it's 1. Right? Next. 8. A black body of temperature T kelvins radiates energy at 10 millivolts. A temperature 2K will radiate energy. Right. Apply Stefan's equation. Q over T equals sigma A T to the power 4. Right. Now Q over T is given. Sigma and A are constants. So Q over T is power actually. So power is proportional to T to the power 4. Apply this equation for these two instances given. In first one, 10 millivolts. T to the power 4. For second case, let's say P proportional to 2T complete power 4. Divide these two. Then 10 over P equals t to the power 4. 2 to the power 4 is 16, no? 16 t to the power 4. These two cancels. P equals 160. Right? P equals 160, it's 5. It's a simple calculation. Only thing you have to know is Stefan's equation, Stefan's law. Only thing you have to know is Stefan's law. Right? Stefan's law එක දන්නවනම් මේ calculation එක easily කරන්න පුළුවන්. Right? මේ calculation එක easily කරන්න පුළුවන් Stefan's law එක දන්නවනම්. Then question 9. Two ideal gases A and B having same value for ratio of principal special heat capacities, specific heat capacities it should be, are kept at same temperature. Mass of molecule of gas A is 4 times the mass of molecule of gas B. The ratio velocity to, this is a question put mistakenly here. This is not a radiation one, but I'll do. So that is a question put mistakenly. This is from gases. This is a gases question, right? Two ideal gases A and B having same value for ratio of principal specific heat capacities are kept at, okay. So we know V for a gas is gamma RT OM, no? Gamma RT OM. This is molar mass. Mass of a molecule is given, no? Okay. Mass of a molecule is given. Then see about the scenario, temperature is constant, no? Kept at same temperature, constant. R is a constant. And B having same value for the ratio. Make it same value for the ratio. Gamma එකත් same කියලා කියන්නේ. Then V is inversely proportional to root 10. Apply this for these two gases. Then velocity of sound in gas A. Then if this is A, VA is proportional to, what about the molar masses? Mass of molecule of A is 4 times. Then this is root 4m. If VB is root m, right? Divide these two. We need VA to VB. Then VA to VB is root m to root m cancels, right? Then root 1/4 means half, right? That is half. Root 1/4 is half. It's a gaseous question, mistakenly put. Right. 10. If the absolute value of surface temperature of sun were 3 times the existing value, the radiation of the sun would have been mostly in. Right. See, if the absolute temperature is 3 times of the value now, right? We know according to Wien's law, from Wien's law, right? From Wien's law, we know lambda T equals K, no? Product lambda T is a constant. Just check what happens when temperature increases. Lambda T equals K. If temperature increases by 3 times, lambda decreases by 3 times, no? If temperature increases, lambda decreases, right? So we know our spectrum. What spectrum? Electromagnetic spectrum, right? Cosmic gamma X, cosmic gamma X, ultraviolet UV, cosmic gamma X UV visible, IR, micro, satellite, TV, and radio. Here, towards this direction, lambda increases. Towards this direction, frequency increases. Frequency increases means lambda decreases. Okay. Now, when temperature is 3 times, lambda decreases, no? Now, currently, we are at visible light. Now, currently, sun is emitting visible light. Listen, currently sun is emitting visible light, right? But when temperature increases, lambda decreases. When lambda decreases, it should emit something in this range, no? Decrease lambda. So it can be either ultraviolet, X, gamma, or cosmic, right? Then here, both X and ultraviolet are given. In this particular year, right, because of this reason, because of this confusion, this question was given as all, right? But here, both UV and ultraviolet are acceptable. Both UV and X-rays are acceptable. But in this particular question, in this year, 2012, 2012 12 or 11 something like that. It was given as a all question. It was considered as a all question. But know the logic, how this is found, right? මෙතන මේ X-ray ultraviolet දෙකක් දීලා තිබ්බ හින්දා confusion එකක් ඇවිල්ලා ඕක all දීලා තියෙනවා. right? හැබැයි එකක් විතරක් තිබ්බනම් අපිට මේකේ answer එකක් හොයන්න පුළුවන් නේ. right? මෙහෙමයි හොයන්නේ. When temperature increases, lambda decreases. When lambda decreases, it shifts towards this direction, this side. මෙන්න මේ ටිකක් තමයි එන්න ඕනේ. right? I hope the logic is clear. Then for this particular question, both X-rays or ultraviolet, it can be either X-ray or ultraviolet. Both are acceptable, right? But just be aware that in that particular year, this was given as a all question. This was considered as a all question, right? 11. A cylindrical copper block of radius r and length 2r. A cylindrical copper block of radius r and length 2r. Radiates energy as a black body at temperature T. If the copper block is cut and separated into n identical discs. Right? This is a good one. Listen. This is a good one. This is a good question. Now, this same block is cut into n number of parts, right? N number of discs. Something like this. It is cut into n number of discs. Right? Then radius remains same, no? Radius remains same. But the length of the disc changes. If the total was 2r and if there is cut into n number of parts, one has to be 2r over n. One has to be 2r over n. One has to be 2r over n. Separated into n identical discs having the same radius r, the rate of the emission of radiant energy, if the above temperature, will increase by a factor of. Right. See, now for this initial one, we can write something like this. Right here, this is a good question. We know Q over T is sigma A T to the power 4. Right? Sigma A T to the power 4. Now, for this radiation, sigma is a constant. Temperature is a constant. Then, if this Q over T is P is proportional to area, no? So I'm going to go ahead with this. P is proportional to area. And if I apply this for the first case, what's the total area here? From the disk, from the plane surface. From the plane surface of the disk, I have a 5r squared. And from the curved surface of the cylinder, right? From the curved surface of the cylinder, we know that is 2πrh, no? The cylinder area 2πrh. Then here that should be 2πr, h is 2r, right? And there are two plane surfaces, then 2πr squared. There are two plane surfaces for a cylinder, this side and that side. Then 5r squared and 5r squared, 2πr squared, and the curved surface, right? Then what is coming here? Here P is proportional to 2πr squared plus 4πr squared. This is 6πr squared, no? This is 6πr squared. This is equation 1. And do the same for the second scenario. Right? Say that is T2 in the second scenario. Then T2 is proportional to, listen. Now, if I think of one disk, if I think of a single disk, one disk, its radius remains unchanged. Then plane surfaces remains unchanged, no? Plane surfaces remains unchanged, right? This side also 5r squared, the other side is also 5r squared. But the area of the curved surface is changing. Now, 2πr is same, but its length is 2r over n, no? Its length is 2r over n. And there are n number of disks. There are n number of disks. Something like this. Simplify this now. Now, for the simplification, if we multiply this by n, see what happens. Before multiplying with 10, let's take 2πr squared out. That's common, no? Right, see, 2πr squared out. Then here 1 remains. Here 2πr squared is out. Then what is remaining? 2 over n remains. times n. 2 of n times n remains. Then if I simplify this a little bit, see what happens. To simplify, let's multiply this by n here. Let's multiply inside by n, right? Easily simplify. Now this is 25r squared. If you multiply the bracket, n plus 2 කියලා එනවා. හරි නේද? 25r squared n plus 2. Multiply the bracket by n. Then n to n cancels in the second part. Then n plus 2 comes. Right? Then this is my equation 2. Right? This is my equation 2. Right? Let me reduce the magnification to do the rest here. Right? Still visible, right? Okay. Now what did I just do? Okay. Right. See? Now, if we need the increase, consider 2 over 1. 2 over 1. Then 2 is 25r squared n plus 2. And 1 is 65r squared. 5r squared cancels. 2 to 6 cancels. Then there is n plus 2 over 3. Right? This is a good question and a different question. A little bit different question. Right? A little bit different question. Right? So first imagine what's happening here. A cylinder, and this same cylinder is cut into n number of discs. Right? Clear enough, right? Next. When the body temperature of a person is 35 degrees Celsius, the peak wavelength of the radiation emitted from the body occurs at 9.4 micrometers. If the body temperature increases to 39, the peak wavelength will be, right? From Wien's law we know, right? From Wien's law, lambda 1 T1 equals lambda 2 T2, Wien's law. Then apply this. First case, lambda 1 is 9.4. The temperature is 35. You have to apply in kelvins, right? What's the Kelvin value? 273 plus 35. 27 කියලා කියන්නේ 300 නේ. එතකොට 35 කියලා කියන්නේ 308. That is 308. We need lambda 2 and T2 when there is 39. And 39 කියලා කියන්නේ 312, right? Then lambda 2 equals 308 over 312 times 9.4. Right? So I think this is divisible by 4. Yeah, it is 308 and 312 divisible by 4. 308 4 times. 308 is 4 times. 75 is 300. Then it should be 77. Right? The main 77. Then 312 is 78, right? Into 9.4. 77 no, 78 into 9.4. 3. Right? It's 3. It's a simple calculation. Only thing you should know is the equation. Wien's law. Equation of Wien's law. Right? That is from Wien's law. Right? Next. 13. A person with surface body temperature 30 degrees Celsius in an environment of temperature 20 degrees Celsius. Right? The net rate of loss of heat due to radiation from the body is proportional to, right? अब मैंने equation ना prove करा. If both emission and absorption occurs at the same time, the net value, total value, is given by Q over T total. Q over T total is Q over T higher value minus lower value, right? If emission is higher, emission minus absorption. If absorption is higher, absorption minus emission, right? Then now in this case, environmental temperature is 20 and body temperature is 30, then emission is higher. Then it should be emission minus absorption. Emission minus absorption, right? Then once the equation is proved, right, what we are getting here is this is sigma A T1 to the power 4 minus T2 to the power 4. Because this is expanded as sigma A T1 to the power 4 and this is expanded as sigma A T1 T2 to the power 4 and sigma is taken out now. So this is what is coming for Q over D total. This is Q over D total. Then apply this here. So it is proportional to Gelahan, it is proportional to, then we don't need these constants. Then this is proportional to these temperature differences T1 to the power 4 minus T2 to the power 4. Then according to what's given here, T1 is 30. Then according to what is given here, T1 is 30. Right? Then Kelvin value is 30 means 303. So it is 303 to the power 4 minus 20. 20 kilograms, 293, right? 293 to the power 4. See how easy this one is. First one. Right? We proved the equation. That's a direct use of the equation. කෙලින්ම equation එක දාන්න අපි prove කරලා තියෙන equation එක දාන්න. කෙලින්ම prove කරලා තියෙන equation එක දාන්න. Right? So I just wrote the equation and explained about the proof because you have to remind it, memorize it. Right? Otherwise, if you know the equation, right? Apply the equation at once. That's it. Apply the equation at once. මොකුත් බලන්න දෙයක් නැහැ. It's a direct application of the equation. Right? A direct application of the equation. Next. 14. The surface temperature of sun is 6000 kelvins. Right? And it emits black body radiation at peak wavelength 500 nanometers. For a black body with surface temperature of 10,000 kelvins, what will be the value for peak wavelength? Right? Again, Wien's law. Lazy anything? Lambda 1 T1 equals lambda 2 T2. Wien's law. Right? At once you can use Wien's law. Then for the first one, wavelength is 500. No? Then 500 into T1 is 6000. We need lambda 2 and the T2 is 10,000. Simplify this. Then these three cancels. 0 to 1, 0 here cancels. Then lambda 2 equals 50 times 6, 300. Lambda 2 equals 300, it's 2. Right? 300, it's 2. Right? Again, a simple calculation. As I told you, matter is comparatively an easy lesson. So that's why I also did this well in advance, even though that's the final unit we have, we covered the lesson in the month of February, right? We covered in February or March. Yeah, we covered the lesson, right? We covered the lesson in March. Right? Practice these questions and make yourself comfortable and familiar with the questions. So easily you can take these questions. Take in the sense you can take the essay one and you are getting like 3-4 MCQs from meta edition, right? MCQs එකත් easily කරන්න පුළුවන්, right? 3-4 MCQs means 3 marks minimum, right? Minimum 3 MCQs, then 3 marks minimum, and a definite essay, 30 marks there, right? And if you are familiar with these things, easily you can score those marks, right? Easy marks. That's the benefit. Right? That's why I took that well in advance in previous class, right? That was the whole purpose. Okay. Then radiation questions are done, right? All the radiation past papers are done now. Let's move on to photoelectric, right? Right. Give me 1 second. And you can ask if any questions, if there's anything to know from radiation questions we discussed. Ask if any questions from these radiation questions we discussed. Right? Okay. Right. Okay. Arne. Let's go to photoelectric questions. Right. Now, when you are joining this S2A, when you are joining this S2A, right? Now, if you can't remember those theories, right? If you can't remember those theories, if you can't remember those theories, right? Listen, if you can't remember those theories, take your notebook out and refer these theories along with the questions, because now we are just 13 weeks from the exam. Refer these theories along with the questions and memorize them. That's a good practice, right? Memorize them with the questions. Memorize them with the questions, right? Then by the end of the session, by the end of the discussion, right, you will memorize all the theories. Now, I discuss about radiation first. Now, all the theories are touched in black body radiation. Then, once you memorize it without losing your momentum, you have to try. Once you do the photoelectric questions now all the theories regarding photoelectric will be memorized, right? Then you can recall them. But again, naturally, it's going to forget, right? Forgetting curve class we have a forgetting curve. So naturally, over time, we are going to forget something. Then, not to forget, if you need to keep them in mind, what you need to do is you have to go through these things regularly, right? So if you refer this, say, once in 3 days, once in 2 days, then you are going to keep them in mind regularly, right? That's normal. That's normal. That's how it should be, right? Again, this is disconnected. Give me 1 second. Right? Today, I think there's something wrong with my connection, right? Something is wrong with my connection today. I don't know why. Something is wrong with my connection. Now it's fine again, right? Okay. Right. So photoelectric කරන්න යන්නේ ඉතින් theories මතක් කරගන්න. Theories මතක් කරගමු. Questions එක theories මතක් කරගන්න. Right. Recall your theories. Recall these theories along with questions. Right. Go to photoelectric. First one. Consider the following statements made about the photoelectric effect. Right. Number of electrons emitted increases with intensity of the incident light. Right. So we proved this. Intensity is proportional to N over T. Right. Intensity is proportional to N over T. We proved this. Right. And with frequency is proportional to K max, V max, and Vs. Right. Variables over the anything. Intensity is with N over T. Right. Intensity is with N over T. And when intensity increases, photo current increases. When intensity increases, photo current increases. When frequency increases, Kmax, Vmax, and Vs increases. Right? Then, first one, number of electrons emitted increases with the intensity of light. Yes. Why? When intensity increases, when intensity increases, N increases, no? One photon emits 1 electron. One photon emits 1 electron. Then when N increases, 1 photon emits 1 electron, no? Number of electrons emitted increases. Number of electrons emitted increases, right? Number of electrons emitted increases with the intensity of light, correct? Right? Higher the number of photons means higher the number of emitted electrons, because 1 electron. 1 photon emits 1 electron. B. Maximum velocity of electrons emitted increase with the intensity of incident light. No, that is not with the intensity, that is with the frequency. I just said that is with the frequency. That is with the frequency. See, maximum velocity of the electrons emitted increases with the wavelength. Then frequency when frequency increases, frequency and wavelength are two opposite things. Look at here. Maximum velocity increases. Maximum velocity increases. maximum velocity increases, Vmax increases with increasing frequency. But when frequency increases, lambda decreases. Always frequency and wavelength are two inverse quantities. They are two inverse quantities. Then this is wrong as a statement. Only A is correct, only A, which means this one. Only A is correct. Right? So that's a theory question. That's a theory question. Right? We have discussed everything in the theories. And the core here is coming from the demonstration part. මතකනේ අපි demonstration එකක් කරා. අනේ demonstration එකෙන් තමයි core area. Core area is coming from the demonstration. Right. Next. 2. A light beam is incident on a photosensitive surface. Right? If the intensity of the incident beam is not changed, intensity is not changed. මෙන්න මම දැන් මෙතනත් ලියුවා මේ intensity and photocurrent is proportional. Then if the intensity is unchanged, which means photocurrent is unchanged. If the intensity is unchanged, photocurrent is unchanged. And also N over T is unchanged. And also N over T is unchanged. If intensity is unchanged, right? I just said in the previous question, if intensity is unchanged, current is unchanged. And N over T is also unchanged. Then beam is not changed. With the following graphs best represent the variation of number n electrons emitted per second. N over T is then I is proportional to N over T. No? Then when intensity is unchanged, N over T is unchanged. Then it should be a constant variation. And we all know minimum frequency required for photoelectric effect is threshold frequency. Right? Minimum frequency required for photoelectric. Then until threshold frequency is reached, there's no photoelectric effect. No electrons are emitted. Until threshold frequency is reached, no electrons are emitted. Then first part is a zero part and second part should be a constant part. So that is very straightforward. Right? First part එක 0 තියෙන equations තියෙන්නේ 1 4 විතරයි. ඊට පස්සේ ඉතින් constant එකක් තියෙන්න ඕනේ. Then that's only 4. That's only 4. Right? Because up until the threshold frequency is reached, no electrons are emitted, no photoelectric effect occurs. Right? No photoelectric effect occurs. Okay, next. 3. Electrons are emitted from a certain metal when monochromatic light, monochromatic means single color. When monochromatic light of wavelength lambda is incident on it, H is the Planck constant and C is the velocity of light. Consider the following statements. Kinetic energy of electrons emitted from the metal is less than Hc over lambda. Right. What is the general equation of photoelectric effect? General equation is E equals 5 plus kmax. No? E equals 5 plus kmax. Right. E is energy of an incident energy packet. Phi work function depends on metal. Kmax maximum kinetic energy. Right. Now first one says kinetic energy of electrons emitted from the metal is less than Hc over lambda. E can be expressed as Hc over lambda. That is 5 plus kmax. Right. Now Hc over lambda is equal to 5 plus kmax. No? Then kmax is on a subject level. Kmax is Hc over lambda minus 5. Kmax is Hc over lambda minus 5. So that is less. Kinetic energy of electrons emitted from the metal is less than Hc over lambda. Correct. That is less. Correct. That is less. Next one. Kinetic energy of electrons emitted from the metal does not depend on material of wire. Metal. No, it depends on phi. Phi depends on material. B is wrong. Phi depends on material. C. Rate of emission of electrons depends on the wavelength lambda. Rate of emission of electrons. Rate of emission of electrons depends on always intensity depends on NOD. Rate of now NOD is rate of incident photons. That is equal rate of emission because one photon emits one electron. Right? So these are also wrong. Only A is correct. Only A. Again a theory question. Right? Right? Only A is correct. 4. A monochromatic beam of light falling on a photosensitive surface and increasing the intensity of the beam. Right. Again, intensity is proportional to NOT. බලන්න මේක repeatedly කොච්චර අහලා තියෙනවද කියලා. Now same thing is used in all 4 questions. now හතරම ඕක මම use කරා. repeatedly same thing is question. Right? Then these are very easily attainable, easily gettable marks because less theories and a small area, a small lesson, right? Easily gettable. An increase of intensity of the beam will increase the rate of emission of electrons. Will increase the rate of emission of electrons. Right? ඒක මාරිනේ ඉතින්. When I increases, NOD increases. Right? අනිත් ටිකත් බලලෙමු. It's a correct one. It's a correct one. Will decrease the rate of no. Will increase the energy? No. Because E equals HF. E equals HF. Will decrease the energy? No. Energy is unchanged. E equals HF. Will not change the energy and the rate of emission of electrons. Rate of emission increases. When I increases, NOD increases. Answer is 1. Right? 5. A metal plate is illuminated with a beam of light of a certain frequency. Which of the following determines whether the electrons are emitted or not from the metal surface? Right? So what it determines is F naught, threshold frequency. Right? That is determined by threshold frequency. Right? Threshold frequency. Threshold frequency. Threshold frequency. Right? And work function depends on metal. Work function is given by HF naught. This is work function. This is work function. Work function. And it depends on metal. Metal means material. It depends on material. I showed you a demonstration also. When metal changes, photoelectric effect changes. Whether photoelectric effect occurs or not, it changes. මං demonstration එකේ පෙන්නනවා sodium වලට මාරු කරලා zinc වලට metal එක මාරු කරලා එක එක දාලා පෙන්නන. Right? Then very straightforward. Which of the following determines whether the electrons are emitted? Which means what is going to determine whether photoelectric effect is going to occur? Right? That is the work function. Work function depends on metal. Then that is type of the metal. Type of the metal. Type of the metal. Right? 6. Right. Which of the following responses contains false information regarding photons and electrons? False information, na? False information regarding photons. Photons are quantum packets, energy packets. Photons are energy packets. Energy is given by HF, right? Energy packets are neutral. Energy packets are neutral. Energy packets are neutral. Right? That's why any electromagnetic wave is chargeless. Right? Neutral again, chargeless. Ne? That's why any electromagnetic wave is chargeless. That's why any electromagnetic wave is chargeless. Right? Cosmic, gamma, X, ultraviolet, visible. Right? This visible light, chargeless. X-rays, chargeless. Right? They are chargeless because they are neutral. They are neutral. Then if that's a neutral particle, they cannot be deflected. Neutral particles cannot be deflected. Right? Just like gamma. Neutral particles cannot be deflected. Then they cannot be deflected. Then if it says it can be deflected, that's wrong. Right? And when it comes to electrons can be deflected. Electrons can be deflected because electrons are negatively charged. Right? Then first one, photons cannot travel at different speed in vacuum. It travels. Right? Cannot travel. No, it's correct. Ne? Because cannot travel, again, velocity of light. Ne? Any electromagnetic wave, photons energy packets. Right? Any electromagnetic wave consists of energy packets. And any electromagnetic wave travels with velocity of light. Right? Then can have different energies. E equals HF. Can have different energies. Correct. E equals HF. When frequency changes, energy changes. When frequency changes, energy changes. E equals HF, no? E equals HF. Right? This is velocity of light. Can be deflected by electric fields. No. Because there's no charge, chargeless. Can behave as particles and waves. Particles and waves. Wave matter duality. Wave particle duality. Wave particle duality. can behave as particles and waves. Wave particle duality is valid for any matter. Valid for any matter, right? Correct. Can eject electrons from materials? Yes. Think ekana දැන් photoelectric effect එක කරන්නේ. So wrong answer is 3. Wrong one is 3. අනිත් පැත්ත check කරන්න ඕනෙත් නෑ. Wrong answer is 3. Can be deflected by electric and magnetic fields. Right? This side is correct, but this part is wrong here in this statement. So final answer is 3. Right? Whole second have we? 7. A photosensitive surface is illuminated separately by light of wavelengths lambda 1, lambda 2, and lambda 3. Right. On all 3 occasions, the intensity number of photons incident per second. Right? That you should know. Intensity is NOD. Intensity means NOD of light is kept at the same value. If intensity is unchanged, if intensity is unchanged, NOT is unchanged. When NOD is unchanged, photocurrent is unchanged. Here unchanged current, then this is wrong, right? So in these two curves, currents are same, right? Here also for now currents are same, right? First two curves are already gone. The current voltage characteristics of the photoelectrons for the situations, right? And we knew this, no? Frequency is proportional to, right? Frequency is proportional to Kmax, Vmax, and Vs, right? And in this graph, right? So we know here we have Vs, here we have Vs, here we have Vs. Then higher the frequency, higher Vs. Higher frequency means, higher frequency means lesser lambda. Higher the frequency, higher the Vs. Then higher frequency means lesser lambda. Then higher Vs should be the least lambda. Higher Vs should be the least lambda. What is the least lambda here? Lambda 3. Least lambda here is lambda 3. Least lambda here is lambda 3. Then lambda 3 should be corresponding to the highest Vs. So that is 4. Lambda 3 should be corresponding to the highest Vs. That is 4. We are using the same theories repeatedly in questions. Right? 26 paper එකේ මේ පාර paper එකේ නේ මේ වගේ lazy mock හරි ප්‍රශ්න. Easily කරන්න පුළුවන්. Right? Theories ටික හොඳට මතක තියාගන්න. Easily කරන්න පුළුවන්. Right? That's the advantage we have. That's the advantage we have in these kind of lessons like matter and radiation. Right? Let's move on. 8. Light of wavelength 500 angstrom is incident on a sodium surface whose work function is 2.28 electron volts. The maximum kinetic energy of emitted photoelectron Hc is given 12.4 10 to the power 3 electron volts angstrom. Right? Okay, then we know general equation of photoelectric effect is E equals 5 plus Kmax. Right? The maximum kinetic energy is asked. Okay, E can be expanded as Hc over lambda. Hc over lambda, right, is 5 plus Kmax. Plug these values. Hc is given 12.4. Product is given 12.4 10 to the power 3, right, over lambda 5000. Lambda is 5000, right? Phi is 2.28, right, plus Kmax. Simplify this. 10 to the power 3 to this 10 to the power 3 cancels. 12.4 over 5. 12.4 over 5 කියලා කියන්නේ what's the value? 2 point. Let me check. 12.4 over 5. 124 over 5 නේ කියන්නේ 120 over 5 කියලා කියන්නේ 24 then 2.48 නේ 2.48, that is 2.48. Then this is going to give 2.48. This is 2.28 plus Kmax, right? Then Kmax equals 2.48 minus 2.28, which means 0.2. 0.2, 0.2, right? 0.2, 0.2. A simple calculation. Equation එක දැනගෙන ඉන්න විතරයි දෙන්නේ. In photoelectric විතරක් නෙමෙයි, in matter and radiation, right? You won't get that much of like difficult, complicated calculations. Very simple, right? Miss කරන්න එපා. අනිවාර්යෙන් කරන්න පුළුවන්. Right? That's the thing. 9. Consider the following statements made regarding the photoelectric effect. This effect can be explained by assuming light as energy packets. Yes, because not even light, not only light, any electromagnetic wave consists of energy packets. Okay. Any electromagnetic wave consists of energy packets. Any electromagnetic wave consists of energy packets. For a given incident monochromatic light, the energy emitted. Listen. For a given incident of monochromatic light, eye connection එක ගියාද? නෑ නේද? One second. Okay, for a given incident monochromatic light, the energy of emitted electrons does not depend on the material. Read again. For a given incident monochromatic light, the energy of emitted electrons does not depend on material. Energy of emitted electrons, that is about kmax, no? What's the equation? Equals kmax, right? Then kmax is E minus phi. So it depends on incident energy and it depends on work function. Work function depends on metal. Work function depends on metal. Work function depends on metal. Work function depends on metal, which means it depends, right? Then for a given incident monochromatic light, energy of electron does not depend. Wrong. It depends. It depends, right? Then then rate of emission of electrons depends on intensity of same thing. Rate of emission of electrons depends on intensity of light. Yes, දැන් මේක හැම question එකෙම තිබ්බ. I is proportional to n over t, right? Correct. Then A and C, only A and C, it's free, right? Only A and C, right? See how easily you can do these questions, right? 10. Blue and red light falling on a certain produce photoelectrons, right? Then about lights, about colors, you have to know frequencies, right? So we know the order, no? මේමනේ යන්නේ Vibgeo, right? මේමනේ තියෙන්නේ Vibgeo කියන මේකනේ තියෙන්නේ. See, Vibgeo, red, orange, මේමනේ යන්නේ මේ ටික දන්නවනේ හැමෝම, right? Green, blue, indigo, violet, and towards this side frequency increases. Then red is the lowest frequency. Blue is somewhere here. Then frequency of B should be, sorry, B name, frequency of red should be less than frequency of blue. Frequency of red is less than frequency of blue, right? ඒක අපි දැනගන්න ඕනේ. Then what does it say? First one, maximum kinetic energy of the emitted photoelectron is higher in blue light. Maximum kinetic energy, again kmax. Now E equals phi plus kmax. E equals hf, no? Hf is phi plus kmax. Then higher the frequency, higher kmax, because phi is a constant for a metal. Then higher frequency means higher kmax. Then maximum kinetic energy of emitted photoelectrons is higher in blue light, right? Higher frequency is blue, no? Then that is higher in blue light. That's correct. First එකම හරි. අනිත් ටිකත් ඕන බලමු. First එක තමයි ඉතින් හරි. Stopping potential is higher in red light, right? අපි මේක දන්නවනේ. See, we know frequency is proportional to kmax, vmax, right? And vs. And stopping potential is higher in higher frequency. Work function of the material of the photocathode is higher in blue. No, work function is a constant for a metal. It is not going to change with the type of wave with the color. Number of emitting photoelectrons always higher for blue light. No, that depends on intensity. That depends on intensity, not frequency. Stopping potential same. No, right? Stopping potential is higher for blue light. Answer is 1. Answer is 1, right? So this is creatively connected to the question here, right? About colors, we are discussing about frequencies, wavelengths, and many other features of colors in waves and oscillations, right? Again, in waves and oscillations. 11. A metal plate is illuminated with light of certain frequency. Which of the following determines whether electrons are emitted from the plate? It is determined by the threshold frequency. It is determined by the threshold frequency. But phi equals HF naught. Phi equals HF naught. Phi is work function. Work function depends on metal. Work function depends on metal. Metal means material. Right? May question right? I can't remember the number of the question now. Right? Check again. We did the same before. Then it depends on the material of the plate. Phi. Straightforward. Very straightforward. Depends on the material of plate. Right? Depends on metal. No? Depends on material. Depends on metal. 12. About question 12. When typing, there has been a small error, right? Mama, ganna vidiya kiyanna. You can check with your own question, right? Otherwise, I think there's a small error in this graph when it is drawn here, right? See, the graph shows the variation of maximum kinetic energy, Kmax, of emitted photoelectrons from metal with frequency. The work function of the metal is, right? Now, Kmax and F is given, no? So first thing, when a graph is given, you have to identify gradient and intercept. Basically, when a graph is given, we have to identify about gradient and intercept, right? Then apply the equation and check it out. See, equals 5 plus Kmax, no? Equals 5 plus Kmax. Then Kmax is at Y and F is given. Then expand E as HF. HF is 5 plus Kmax. අපි මේ graph එක class එකේ ඇඳලා තියෙන්නේ. I think we draw around 15, 16 graphs, and this is one of the graphs. Right? This is one of the popular graphs. We draw around, I think 16 graphs. Right? That's quite a good amount. Then subject Kmax. Kmax is HF minus 5. See, now you can identify these variables. F is my x axis. Then H is, it has to be my gradient, M. Minus this is going to be intercept, C. Kmax is Y. Y equals mx minus C. It is aligning with the given graph, no? Then C equals 5. Work function is given by intercept. Work function is given by intercept. Then what you have to do is extend this given line and check the intercept. Extend this given line and check the intercept. There's a small deviation from the supposed graph here. In this case, there's a small deviation from the supposed graph when it is typed here, right? So this is what you should do, and it should be intersecting at 2.5. It should be one second. See, right? Extend this and see now in this particular the problem is, listen, in this particular one, the problem is with the scale. Make a scale product, right? In the original paper, you can check with the original paper, right? Extend it. So it is intersecting at a point less than 3. It is intersecting at a point less than 3. Then only answer we can get is 2.5, right? So what you have to do is extend the given line until it is intersecting y, because I need to find intercept. I need to find intercept. Intercept is the work function, no? Intercept is the work function, no? I need to find the intercept. Need to find the intercept. Right? That's the thing. Clear, right? Clear enough? Clear enough, maybe? Let's move on. 13. Electromagnetic radiation of frequency f is incident on a photosensitive surface of which threshold frequency for emission of photoelectrons is f naught. Threshold is given f naught. Which of the following is not true? Which of the following is not true? Right. No photoelectrons are emitted when f less than f naught. Because minimum frequency required for photoelectric effect is threshold frequency. If the frequency is less than threshold frequency, no photoelectric effect. Correct. F naught is a characteristic feature of the material. Yes. We met the same thing before in last 3-4 questions. When f is greater than f naught, the rate of emission of photoelectrons increases as the intensity of incident radiation increases. Yes. Intensity intensity is proportional to n naught. Correct. The stopping potential is rate proportional to f squared. That is not f squared. F proportional to k max, v max, v max, k max, v max, and vs. Right? Because it is coming from this hf equals pi plus k max. Right? So this is just frequency, not the square. That's wrong. 4 is the answer. The stopping potential is independent of the intensity of incident radiation. Stopping potential, yes. Because stopping potential depends on frequency. Stopping potential depends on frequency. Right? So it's 4. For 13, it's 4. It's 4. Right? Theory parts. 14. The work functions of corresponding two metals A and B are W1 and W2. Right? W1 and W2 respectively. And W1 is greater than W2 work functions. Now it is given as W. Phi is given as W now. Two surfaces made of A and B are illuminated separately using a monochromatic beam of light of frequency f. Which of the following graphs correctly represents the variation of maximum kinetic energy K max of the emitted photoelectrons with the frequency? Right. Now W1, this is given. W1 is greater than W2. Function is greater than phi 2, right? Because we are familiar with phi, no? We are familiar with phi. So it's convenient for me to, it is convenient for me to convert that to phi. That is convenient. Then phi 1 is greater than phi 2. Right, see? Graph එක check කරගන්න ඕන නම් equation v phi plus k max. මේ graph එක මම කලිනුත් තන්දා. E is hf. hf is phi plus k max. Subject k max. K max is hf minus phi. Right? Identify our variables. F is x. Then h is gradient. This is c. This is y. Then mx minus c. mx minus c. Now, from this gradient is h and intercept is phi. Gradient is h and intercept is phi. Right? Then, whatever the curve it is, gradient is h, Planck's constant, then gradient should be same. Since gradients are same, these different gradients are wrong. These different gradients are wrong. Right? It should be parallel. Gradients are same. Same gradient means same angle, same tan theta. Right? Then C is work function. No? Higher work function has a higher C. Higher work function has a higher C. Right? So higher C is with A. Then answer is 2. Higher C is with A. The answer is 2. Right? C එක පේන්නේ නැත්නම් ඉතින් මේක extend කරලා බලන්න මේ graph එක extend කරොත් මේකෙන් මේ පැත්තට මේකෙන් මෙතෙන්ට. So this is a higher C, higher intercept. Answer is 2. Right? Simple. හරිනේ? 15. 15. A, B, and C are three metals with threshold wavelengths lambda A, lambda B, and lambda C. Right. Threshold wavelength. What is threshold wavelength? Threshold frequency means minimum frequency. F node. Threshold frequency is minimum frequency to emit electrons for photoelectric effect. Right. And lambda naught is maximum lambda. Because when frequency decreases, lambda increases. They are inverse. Right. මේක තමයි මෙතන theory part එක. Threshold wavelength is the maximum wavelength to emit photoelectrons, right? Respectively for photoelectric emission. Photons of frequency 1.2 times 10 to the power 15 Hz are incident on each of the metals. Photoelectrons are emitted at the speed of light in. Right. Then let's check the lambda of this given one. Let's check the lambda of this given one. Right. Frequency is given. If frequency is given, we know V equals F lambda, which means C equals F lambda when travels with velocity of light. Right. C is given 3 times 10 to the power 8. Right. Frequency is given 1.2 10 to the power 15. I need lambda. Right. Then check lambda 10 to the power 8, 10 to the power 7 remains. Then 300 over 2 30 over 12 කියලා කියන්නේ 2.5 නේද? Yeah, it is 2.5, which means that is 0.25 micrometers. Listen, the lambda of this one is 0.25 micrometers. Threshold wavelength is the maximum wavelength. Now, this threshold is 0.3 maximum. Then, for any wavelength that is less than 0.3, it occurs no. Then, for A, it is possible. Right? For B, 0.28. For any wavelength less than 0.28, it occurs. 0.25 is less, so B is also fine. For C, 0.2. 0.2. For any wavelength less than 0.2, it occurs. 0.5 is higher. So C, it is not going to occur. Then only for A and B. Only from A and B. Right? Only from A and B. Right? So not a big deal, not a big deal. 16. A beam of monochromatic light is incident on a metal surface, which is capable of producing photoelectrons. If the frequency of light is above the cutoff frequency means threshold. If the frequency of light is above the cutoff, which means a photoelectric effect occurs. Right? The number of photoelectrons ejected from the metal surface proportional to number of photoelectrons. Intensity is proportional to N over T. Right? This is the nth time we are using the same thing. Right? Then number of photons, right? Number of photons sit on the metal surface. Number of photons, NOT. Number of photons sit on the metal surface. Right? බලන්නවත් දන්නේ නැහැ. Easily ගහන්න පුළුවන්. 17. Part of an orbiting satellite is coated with a metal that has a work function of a small printing mistake. This should be corrected as, this part should be added actually. Work function of 5 electron volts. Work function of 5 electron volts. Right? Please add it. 5 electron volts. The Planck's constant is 4.1 times 10 to the power 15 electron volt seconds. And the speed of light is 3 times 10 to the power 8. What could be the longest wavelength of incident sunlight that can eject electrons from the metal coating? Right? Longest wavelength. Longest wavelength. Longest wavelength. Longest wavelength කියලා කියන්නේ මොකද්ද? Maximum wavelength. Maximum wavelength means threshold wavelength. Lambda naught. Right? Longest wavelength means maximum wavelength. Then that is about threshold, lambda naught. So we know work function is expanded as Hc over lambda naught. Work function is expanded as Hc over lambda naught. Right? Work function is given, right? 5 electron volts. 5. H is given 4.1 10 to the power minus 15. C is given 3 times 10 to the power 8. We need to find lambda naught. We need to find lambda naught. We need to find lambda naught. Right? Simplify. Then Anything cancels? No. Ah, 3 cancels ne? 3 cancels. See? Then 30 කියන්නේ 6 නේ කියන්නේ 3 කියන්නේ 0.6. Then only number you are going to get here, number එක විතරක් බලන්න. Only number you are going to get here 4.1 times 6 as a number. Right? 4.1 times 6 is 4.4 times 6 කියලා කියන්නේ 24 නේ. 0.1 times 6 කියන්නේ 0.6 නේ. Then that is 24.6. Then the number is 246. 10 to the power බලන්න ඕනේ නැහැ. You have different numbers given. Right? You are trying MCQ. Then if you see this as different numbers, don't check the 10 to the powers again. Check the number. Right? Then 246. Easy. Right? Next. 18. Again, a theory part. A metal surface is illuminated. With monochromatic blue, red, and yellow. And again, our frequencies on it. Right? How many frequencies? Right? This is how frequencies change. Along this direction, frequency increases. Right? Then compare these frequencies. Red is given. Red is the minimum frequency. Then frequency of red is minimum. Then what are the given colors? Red, blue, and yellow. Then frequency of yellow is in between, and frequency of blue is the highest. Frequency of blue is the maximum, highest. First one, consider the following statements. First one, A. If red light ejects photoelectrons, then blue light should also eject photoelectrons. If red light ejects, we know photoelectrons are ejected if threshold frequency is increased, is gone beyond, threshold frequency is passed. Photoelectric effect is occurred if threshold frequency is reached only. Right? If threshold frequency is reached. Now it says red light emits photoelectrons. Again, red frequency is enough. But these frequencies are greater than 100, no? These frequencies are greater than 100. Then we can't say blue is going to eject. No. Because blue has a higher frequency. Wrong. Blue has a higher frequency. Lower frequency ko kuna nang hari. Lesser frequency ko kuna nang hari. Higher ekkada giyanna bෑනේ. Harane? Then next one. Next. B. If yellow light ejects photoelectrons, then red light should also eject photoelectrons. It's correct. Yellow that's a frequency greater than red. Then if for yellow light, if photoelectric effect occurs, which means for any frequency less than that, it occurs, no? Right? Yellow wala tiyana ekkanata photoelectric එක වෙනවා. Right? Next one. If yellow light ejects photoelectrons, then red light should also eject photoelectrons. See, if blue light ejects photoelectrons, then blue light has reached. මං අනිත් පැත්තට යන්න තියෙනවා. Wait. Hi, first again අයියා. If red light eject photoelectrons, red එක photoelectron එක කරනවා. Right? Red ejects, which means threshold frequency is අනිත් පැත්තට යන්න තියෙන. Threshold frequency is equivalent to frequency of red, no? Threshold is the minimum. මේ තියෙන minimum එක. Then for these two also it occurs. හරි. අනිත් පැත්තට යන්න තියෙන wavelength එකක් එක්ක පෙරලනවා. Right? See? F naught is the minimum. Now for the first one, for red light, if photoelectric effect occurs, for red, photoelectric effect occurs, which means red has already reached F naught. That's the minimum value. Then for these two frequencies which are greater than red, definitely it occurs. Then first one is correct. B. If yellow light ejects photoelectrons, yellow වලට eject කරනවා කියලා කියන්නේ නේ. Yellow වලට eject කරනවා කියලා කියන්නේ threshold frequency is relevant to yellow now. මේ තියෙන minimum එක. This is the minimum. මීටත් වඩා අඩු එකකට මෙයාට ෆොටෝ ඉලෙක්ට්‍රික් කරන්න බෑනේ. That's the minimum, no? That's the minimum. Then red also ejects, no. එහෙම කියන්න බෑ. Then blue. If blue light ejects photoelectrons, blue light eject කියලා කියන්නේ threshold frequencies with blue now. That's the minimum, right? මේක තමයි minimum. ඊටතර මීටත් වඩා minimum මේවට කරන්න බෑ. That's the minimum now. If blue light ejects, no, it's also wrong. Then only A. For 18, it is only A. Only A, right? That's all. See, simple arguments. Simple arguments. Right? So, whole purpose behind these S2A discussions is to make you familiar with these past paper questions, no? Right? Then cover these things in the live, as a live, because you are just 13 weeks from the exam. In the live class, cover everything, and that's it then. I make a passe balanda. Now, this is the 12th day, right? I think now we have discussed a subsequent amount of, a substantial amount of questions. This is the 12th day. We are doing this today, right? And in the coming weeks also, I'll be keep doing, right? I'll be keep doing this, right? Then get the advantage. Get the advantage. Okay. Any questions from the things we discussed today? Any questions from the things we discussed today? Any questions? Feel free to ask if anything, right? Now we have come to the end of the discussion. Any questions? Are you all good? Are you all clear? Are you all good? All clear? Any questions? I think we discussed around 35-40 questions today, right? Any questions? If you have anything to know from my side, feel free to put into the live chat. If you have anything to know from my side, feel free to put into the live chat. Anything? And from matter and radiation, the other parts remaining are radioactivity questions, right? Radioactivity questions are remaining. That's the main part actually. Radioactivity මතකයිනේ. Age calculations, nuclear binding energies, radioactivity, decay constant, law of radioactive decay, right? අන්නේ part එක තියෙනවා. අපි ඒක discuss කරමු next week, right? Next week අපි ඒක discuss කරලා මේක ඉවර කරලා දාමු. ඊට පස්සේ x-rays වල questions, ඒ කියන්නේ particles and waves කියන part එක තියෙනවා. ඊට පස්සේ quarks and leptons, quantum particles, ඒ part එක තියෙනවා, right? So those two are the coming up parts in photoelectric, right? So as we have covered everything, covered all theories in month of March, right? You can go through the theories again and again, practice these questions, practice the questions in the past papers, and join the discussion, join the S2A session. Then you can easily improve yourself, right? When you have practiced the questions, right? These all questions from radiation and no, that's what I just said. From matter and radiation, radioactivity remains, and particles and waves. Then partial physics. Partial physics means leptons and quarks. Quantum part එක තියෙනවා, right? So we can finish those questions, I think, by next week. How many questions remaining? 27, 7, 34. Yeah, around 38 questions remaining. We can cover it from a single day, right? After finishing radiation, again I'll be taking a lesson like thermal law, electricity, current electricity, or something like that. Let's see, right? Okay. Any other questions? Any other things to know? Anything else? Anything else? Anything else to know? Anything else? All good? Okay then. If no questions, we'll wind up, right? We'll wind up. If no questions, right? Get all updates from the channels, and you can join other future sessions also. Okay then. What's the time? 10:37. Okay. We'll finish this now, right? Okay. No questions. Okay. Right. Right. Okay. Then stay safe and work hard. Right. We'll see you again in the next class, right? Good night and goodbye. See you.